Opening. Balance the chemical equation. Okay, please pause the video, see if you can solve this. And if you can't balance the chemical equation, I will show you how to do it. Please pause the video now. Okay, we're back. Let's see what we have here. We're going to take phosphorus and we're going to react it with dioxygen and we're going to produce something interesting. This is a covalent molecule. How do I know that? Well, it's two nonmetals bonding together. So it's diphosphorus pentaoxide. And how would we balance that? Let's take a look. Okay, so I'm going to divide my reactants from my product and I'm going to create an inventory list. We have phosphorus and oxygen, and we have phosphorus and oxygen. We have one phosphorus here, we have two oxygens here, we have two phosphoruses here, and 5 oxygens here, so not balanced at all. So no matter what coefficient I put here, well, no matter what coefficient I put here, I'm not going to be able to get an odd number. So I need to turn this side into an even number. And I can do that with a 2, I can do that with a 4, I can do that with a 6. But let's start with something simple. Let's start with a 2. And that would turn phosphorus into a 4. And that would turn oxygen into a 10. Because 2 times 5 is 10. Okay, can I turn phosphorus on this side into a 4? Well, that's pretty easy. And then can I turn dioxygen into a 10? Actually, I can do that pretty easily as well. 5 times 2 is 10. And look at this. Phosphorus is 4 on this side, it's 4 on this side, oxygen's 10 on this side, oxygen's 10 on this side. Ladies and gentlemen, it is balanced. And we balanced it with the coefficients 4, 5, and 2. And we would say this has a molar ratio of 4, 5, and 2. I'll talk more about molar ratios next time, but just remember, that's what those coefficients mean. We have a molar ratio of 4, 5, and 2 to balance this chemical equation. All right, so ladies and gentlemen, what we are doing today is stoichiometry. Stoichiometry is the quantitative relationship of reactants and products in a chemical equation. Would you pause the video and write down that definition? All right, we're doing stoichiometry. Let's do another one. Balance the chemical equation. This is an interesting equation because now we're starting as a reactant with just one thing, and it's going to become two things. That happens sometimes in chemistry. When that happens, we call it a decomposition reaction because this is going to decompose into two less complex molecules. So let's see if we can do that one. All right, so once again, we're going to divide our reactants to our products. And we have 3 elements this time. We have potassium, we have chlorine, and we have oxygen. And we're going to do the exact same thing on this side as neatly as I can do it. And let's take an inventory. We have 1 potassium, 1 chlorine, and 3 oxygens. We have 1 potassium, 1 chlorine, and 2 oxygens. Okay, so I need to either turn this oxygen into an odd number. No, I can't do that, but maybe I can turn an odd number into an even number. So let's work on this side. Oxygen is going to be the problem in this equation. So I'm going to work with oxygen, and I'm going to work with the odd number. Let's turn it into an even number. All right, so when we put a 2 here, remember it doubles the whole molecule. So that turns potassium into a 2. Chlorine becomes a 2. And oxygen, 2 times 3 is 6. All right. And now we need oxygen to be a 6. So if I just put a 3 here, 3 times 2 is 6. And now all we need is potassium and chlorine to be 2 each. Well, that's pretty simple. Look at that. I think we did it. Potassium's 2 and 2, chlorine's 2 and 2, oxygen 6 on this side, oxygen 6 on that side, and ladies and gentlemen, that means it is balanced. It is balanced with a molar ratio of 2, 2, and 3. All right, let's do another one. Balance the chemical equation. Oh, this is interesting. Zinc is going to combine with copper sulfate. SO4 is a polyatomic ion called sulfate, and it's going to yield zinc sulfate and copper. So do you see what happens here? The sulfate is going to stay together, but the copper is going to leave the sulfate and zinc is going to join the sulfate. Here we have zinc by itself. On this side we have copper by itself. So they're going to replace each other. And let's see if we can balance that chemical reaction. All right. I like to draw a line down the middle. You don't have to, but you can. And we have zinc. We have copper. And since the polyatomic ion's not going to come apart, we can leave it as a single unit, just like this. Zinc, copper, and sulfate. We're treating this like it's an element, even though it's not. Zinc, copper, and sulfate. So this isn't the same order as this, but I want it to be the same order as this so I can do an easy comparison. And whenever you set up a problem like this, try to make it as easy as possible for your brain to process it so that you're focused on the balancing of the chemical equation. You're not focused on trying to find where did you write zinc and where did you write copper. You want to keep things together. Okay, we have one zinc here, one copper here, and one sulfate polyatomic ion. We have one zinc here, one polyatomic ion here, and one copper. Is it balanced? We have 1 and 1, we have 1 and 1, and we have 1 and 1. Guess what? You do not need to do anything with that one. It is already balanced. It's balanced with coefficients of 1, 1, 1, and 1. We would say it has a molar ratio of 1 to 1 to 1 to 1. Sometimes that happens. You don't have to do any work. All right, let's do another one. Okay. Oh, this is interesting. Do you remember what CH4 is? This is methane. We're going to react it with dioxygen, and it's going to yield two things. It's going to yield carbon dioxide, and it's going to yield water. What makes this so interesting? This oxygen right here is going to divide up and be used for two different molecules. Some of the oxygen is going to be used to make carbon dioxide, and some of the oxygen is going to be used to make water. So the oxygen is actually going to divide up into two different things. That always makes the problem more complex. So let's see how to solve that one. I'm having trouble drawing. Oh, there we go. Well, we just need one line. Okay. Carbon, hydrogen, and oxygen. On the product side, carbon, hydrogen, and oxygen. Even though we see oxygen in two different places, we're only going to take one count of it. So this is the proper way to do it. How many carbons? 1. How many hydrogens? 4. How many oxygens? 2. How many carbons? 1. Let's save oxygen for last. How many hydrogens? 2. And how many oxygens? I almost wrote 2, but no, there's 1 over here. So 2 plus 1 is 3. And that's what you have to do. If they're separated, you have to add them. So not very balanced. Looks like turning hydrogen into hydrogen is not going to be so hard. It's this even number and this odd number that are going to make the problem difficult. So let's focus on the oxygen, especially since they get split up. Let's see here. Let's see. We can put a 2 here. And what does that do? Now we have 2 oxygens plus 2 oxygens. Now it's 4 oxygens. And because we put a 2 in front of H2O, the H becomes doubled. That becomes a 4. All right, we have 1, 4, and 4 on this side. We have 1, 4, and 2 on this side. So this oxygen needs to be doubled. Well, actually, that's not so hard to do. And I think we did it. We have 1 carbon here, 1 carbon here, 1 hydrogen here, 4 hydrogens here, 4 hydrogens here, 4 oxygens here, and 4 oxygens here. Ladies and gentlemen, it's now balanced with a molar ratio of 1 to 2 to 1 to 2. And I've done lots of these over the years, so I'm pretty fast with it. But a lot of times you get started with a problem like this and it gets messed up and you have to start all over again and you have to cross things out and you just have to start over. Nothing wrong with starting over. Some of these take 10 or 15 minutes to solve, so please be patient. Don't give up. Have a fun time with it. It's like solving a crossword puzzle. It is enjoyable to figure out something that is difficult to do. And that is my lesson on balancing chemical equations. You can't really learn it by watching me do it. I want you to practice and do them yourself. The end.